Have you ever wondered how we can identify flood-prone areas or plan cities more efficiently? This is where GIS or Geographic Information System plays an important role. GIS is a technology used to collect, store, analyze, and display spatial data based on location. By using maps, GIS helps us understand patterns, relationships, and changes in a clearer way. GIS is widely used in many fields such as environmental studies, urban planning, disaster management, and transportation. It helps decision makers plan better solutions to real-world problems. There are two main types of GIS tools, which is desktop GIS and web GIS. Desktop GIS such as ArcGIS Pro and QGIS is used for detailed spatial analysis and map creation. It works offline and is suitable for handling complex data. Meanwhile, web GIS such as ArcGIS Online, Mapboard, and Leaflet allows users to share and view maps online. It is easy to access and supports collaboration. GIS tools help transform spatial data into useful information for better decision making.
Hello, my name is Dennis Ahmad bin Osman, and I will tell you how about to create a map using QGIS. First of all, you should install QGIS 3.44 in your device such as computer or laptop. Now after installing QGIS, make new project, create map, double click on first street. Now the new map are shown. Zoom in to Malaysia. Now download the data on the website, unzip the file and extract all. After the extract, find the data in the browser and the data found it. And the data are shown on the layers. Right click on the MYS ADM BNDA ADM1 and open attribute table. Now start editing the table. Add field on the name, type forest, type pick 1.2 decimal number, real, length change to 10 and precision change to 1 and click OK. Now insert the data in the attribute table. Take the data for years 2021. This is for Johor. This is for Kedah. This is for Kelantan. This is for Melaka. This is for Negeri Sembilan. This is for Pahang. This is for Perak. This is for Perlis. This is for Pulau Pinang. This is for Sabah. This is for Sarawak. This is for Selangor. This is for Terengganu. This is for wilayah Persekutuan Kuala Lumpur. This is for the wilayah Persekutuan Labuan. This is for wilayah Persekutuan Putrajaya. After that, save and stop editing. After that, right click on the My ADM1 to rename layer and change it to reserve forest. Now, right click on the reserve forest and click properties. Next, click on the symbology and click graduate. On value, click 1.2 forest and adjust the symbol, any symbol you like. On color ramp, choose any color you like and click OK. For mode, choose equal interval, choose. For classes, choose 5, click apply and OK. This is the result of corolla plot map of reserve forest. Now click Plug in. And type quick OSM and install it. After done installing, close it and go to vector and choose quick OSM. Click quick query and type forest and choose it. On type Malaysia and run query. Wait for it. Now the result are shown on the maps. It will show the location on the state. Now go to plug in again. And type QGIS 2. Click install it. Go to web and choose QGIS web and create new map. It will show export to web map. Find ADM1 EN and change to inline table visible with data. Slide down and find shape long and choose inline table visible with data. Find shape area and choose inline table visible data, and find forest and change to inline table and click export. Make sure it's all done and then click to export the map. is the result of WebGIS using QGIS to web.
Application to environment or spatial problem, flood mapping and environmental problem. Flood mapping environmental problem, flooding during monsoon season common in low-lying and river areas. The specific environmental challenge addressed is flood mapping. Flooding during the monsoon season is a common and serious issue, particularly in low-lying areas and regions adjacent to rivers. GIS tool use QGIS or ArcGIS Pro, ArcGIS Online or Web GIS. To tackle this, industry standard GIS tools are utilized. These include desktop applications like QGIS and ArcGIS Pro for detailed analysis, as well as ArcGIS Online for web-based GIS solutions allowing for broader access and sharing of information. Spatial data, elevation DEM, river networks, and land use data. Effective flood mapping relies on specific spatial data inputs. Key data sets include elevation data, often in the form of a digital elevation, model dam, DEM to understand topography, data river networks to trace water flow, and land use data to identify vulnerable areas like residential or agricultural zones. GIS analysis, buffer analysis around rivers, overlay of elevation and land use.
For this slide, I will explain the comparison and evaluation of desktop GIS and web GIS. Let's start with usability. Desktop GIS offers powerful and advanced spatial analysis tools such as 3D modeling, geostatistical analysis, and map overlay. However, it requires technical knowledge and training, and the interface can be complex for beginners. On the other hand, WebGIS is user-friendly with a simple and interactive interface that anyone can use, even with limited GIS experience. Examples include Google Earth, ArcGIS Online, and OpenStreetMap. Next is scalability. Desktop GIS depends on your computer's hardware and storage capacity, which limits its performance when handling very large datasets. WebGIS is cloud-based and highly scalable, allowing multiple users to access and edit maps simultaneously, which is ideal for collaborative projects or public mapping services. For accessibility, desktop GIS requires installation and often paid license, so you can only use it on certain devices. WebGIS is accessible anywhere through a web browser, which is make it convenient for fieldwork or sharing maps with the public. Okay, now let's move on to limitations. Desktop GIS can be expensive, hardware dependent, and less suitable for teamwork. WebGIS may lack advanced spatial analysis features and relies on a stable internet connection. After that, potential improvement include simplifying the desktop GIS interface for beginners and enhancing collaboration features. WebGIS could improve advanced analysis tools, strengthen data security, and provide offline access for areas with poor internet. In practical applications, desktop GIS is often used by urban planners, environmental scientists, and engineers for detailed analysis. WebGIS is widely used in public mapping, disaster management, and tourism apps, where accessibility and collaboration are important. In conclusion, Desktop.js and WebGIS each have unique advantages. Desktop.js is best for detailed technical analysis, while WebGIS offers accessibility, ease of use, and collaboration. Choosing the right system depends on the user's need, project skill, and technical skill. That's all from me. Thank you.
Good day! Today, I will present my project on QGIS tools and their applications. This project mainly uses QGIS as the desktop QGIS software. QGIS is an open source platform that allows users to manage spatial data, create maps, and perform spatial analysis. In this project, QGIS was used to prepare maps and visualize spatial information before presenting the result in a web-based format. This slide shows how spatial data is managed in QGIS. Several vector datasets were imported, including administrative boundaries and base map. The layer panel located at the bottom left was used to manage multiple layers and control their visibility. The attribute table displays detailed information for each spatial feature, which supports accurate data handling and map preparation. In this slide, symbology and map design are demonstrated. Different color and symbols were applied to each layer to clearly distinguish spatial features. Standard map elements such as the map title, legend, scale bar, and node arrow were added. This ensures that the maps are clear, consistent, and easy to interpret. This slide presents the spatial analysis process using QGIS. Basic QGIS analysis was applied to support spatial interpretation and identify patterns. The analysis results were then visualized in the form of maps. This process helped transform raw spatial data into meaningful geographic information. After completing the map preparation and analysis, the outputs were presented as a web-based map. The web map allows users to interact with the data through zooming, panning, and layer control. This slide demonstrates a web map simulation, showing how GIS data can be shared and accessed in an interactive and user-friendly way. This final slide summarizes the digital skill demonstrated in this project. The map shows spatial data from different years ranging from 2011 to 2021, which allows comparison of spatial change over time. Using QGIS, I manage multiple layers and apply consistent symbology across all maps. QGIS analysis was used to identify spatial patterns and difference between years. Finally, the results were presented through a web map simulation. Overall, this project strengthened my QGIS skills and enhanced my understanding of spatial data visualization and analysis.
In conclusion, GIS tools play an important role in analyzing and visualizing spatial information. Desktop GIS is powerful for detailed analysis, while WebGIS is effective for sharing maps and improving accessibility. Both tools help us solve real-world environmental and spatial problems. Through learning GIS, we also develop important digital skills such as data handling, mapping, and spatial analysis. These skills are useful for our studies and future careers. With the advancement of technology and real-time data, GIS will continue to grow and become even more important in the future. That's all for our presentation. Thank you.